So I think it's easy, right?
Yeah.
Okay. So this one, it sounds like negative 14. Let me write it. Positive or negative? No, this one's it's going to be 196.
Yeah.
Plus, need to turn this one into plus. Times 45 is 90. Times 2 is 360. Divided by 4, right?
Yeah.
Also going to be negative 14. Positive or negative?
Square root.
So I have a couple of solutions. The first one is negative 14 plus root 556 divided 4. Let me assume this part is x1. x2 is going to be the same thing. Negative 14 minus square root 556 divided by 4, right?
Yeah.
But he asked me to write it in a decimal, which makes sense. That in this case, you have to use your calculator to be able to get it. Okay.
Yeah.
This one clear for you?
Yeah.
Do it again or understand it?
Understand it.
Oh, but wait, hold on. I need to tell you something. Now, the last thing I need to share it with you, you would have a couple solution, but one of them it must be rejected. But why one of them it must be rejected? If you have a negative, so it doesn't make any sense that we have a side length it's going to be a negative. So, I mean, the one who is negative, it must be excluded, right?
Yeah.
So, I think this one must be excluded. I'm gonna back up this one. Okay. So let me try to go for this one. He asked me what is to calculate, the length of AE. Okay. So
Yeah.
the point is, he told me that the area of the triangle ADE, it sounds like 160. But I don't think this one, it doesn't look like a right angle triangle. So if you have something, doesn't look like a right angle triangle. So in this case, you have to use, the area formula, which is supposed to be half times side length times the other half times, the couple sides times the sine, the angle between them. So what I want to do, just try to write it down, that the area equals to half multiplied by A multiplied by B sine the angle, right?
Yeah.
So, but where is, I need to figure out firstly, where is the angle, right? So look at this one. Let me tell you the problem. Okay, look at this one. So that one is right angle. So 818. This one is 6 centimeter, and this one also is 18 centimeter. So the point is, I need to figure out what is AE stands for. This one sounds like missing, right?
Yeah.
I don't have it. So the point is, firstly, I have a couple missing, right? I don't have this side. I don't have the angle as well. I meant this one also. I don't have it, right?
Yeah.
So I need to handle this problem, which makes sense. I need to figure out this one firstly. So the point is, I tend to use the smaller triangle firstly. I have the ability to get, this angle. right? I meant to get the sine of that. So if I assume this part is x, for example, so what is sine x? Could you tell me what is sine x? It's going to be
What?
opposite over hypotenuse, right? You have the
Yeah.
opposite, you have the hypotenuse as well. So it's going to be 8 over
Um, 8 over 8 over x. 180.
no, I need to get this one, right?
Yeah.
So that one sounds like if we try to apply sine rule, a sine, so it's going to be opposite over
Yeah.
hypotenuse.
18. Yeah.
So it's going to be 8 over 18, right?
Yeah.
So do you have the area? The area has been given already. 160, right?
Mm-hmm.
So let me write it. The 160 equals to half multiplied by the first triangle. I meant the first side, which is going to be AD times first side times the second side times AE sine the angle between them, sine A, right?
Yeah.
And sine A, got it already, the 8 over 18. To make sense, this one's going to be 160, which equals to half multiplied by 80. What is 80 stands for? 80 is going to be the sum of them. It's x plus 18. So this one's going to be 24 multiplied by AE. I don't know what AE stands for, so let me write it down. Sine A, what is sine A? What is sine A?
Oh, 8 over 18.
8 over 18, right? So, yeah, okay. So listen. So one, I can make it simple. So it's going to be 160 equals 12 AE multiplied by 8 over 18, right?
Yeah.
Did you get it? And then if you want to do a symbol, this one, it's going to be, I could multiply 12 times 8, right?
Yep.
Divided by 18, because I need to make it simple. So it's going to be 160, which equals to 12 times 18 is 96 divided by 18. So in the simplest form, so it's going to be 16 over 3 AE, right? If you need to get what is EE stands for, so you could use your calculator, just choose the cross multiplying, which is going to be 3 times 160 divided by 16, right?
Yeah.
So this one's going to be 10. 160 divided by 16 is going to be 10, so AE it's going to be 30. Did you get that?
Yeah.
Or it's still hard?
Maybe we do it one more time.
Yeah, sure. Okay. Look at this one. Let me take a screenshot. Is it clear for you?
Yeah.
You know, I was talking about that. I mean, the largest triangle that we have, which is going to be ADE. Do you think this triangle is right angle triangle? I don't think so, right?
No.
So in this case, you have to remember the rule. So in this case, the area equals half times AD times
CE. AE.
right? I'm talking about the greatest one or the largest one. So it's going to be A times AD times AE times or sine the angle between them, sine A, right? Did you get it?
Yeah. Yeah.
But the point is, I don't know what is sine A, right?
Yeah.
But we got something that's really, really interesting. Look at this one. This one, it looks like a right angle, right?
Yeah.
Which makes sense. I have the ability to get what sine A stands for. So let me write sine A equals to opposite over hypotenuse. Do you know why did I pick up sine A in a specific?
Yeah, because we're trying to find out A.
Yeah, because we are trying to find out what is the area, right? And the area depends on, if you want to get the area of the triangle, it depends on the sine rule, right?
Yeah.
Okay, so I have the opposite, so it's going to be 8 over 18, right?
Yeah.
Did you get it?
Yeah.
Okay, do you have the area?
No.
Yeah, you have it. It's been given already.
Yeah, yeah, I know. But like I thought you meant like of the second half triangle.
So what is the area?
160 divided by 2.
Let me write 160, right? Which equals to half times 80. What is 80? I mean the entire side. It's going to be the sum
Uh,
of
24.
multiply AE.
I don't know.
I don't know. I don't have it. I need to get it. So let me write AE multiplied by sine A. What is sine A?
Uh, 8 divided by 18.
Yeah, let me write it. 8 over 18, right?
Yeah.
You know, the point is, look at this one. 24 divided 2. Let me write down 160 equals to 12 multiplied by AE multiplied by 8 over 18, right?
Yeah.
And then what I want to do is just try to multiply 12 times 8. 12 times 8 is 96 divided by 18 after being simplified. So it's going to be 16 over 3. When you write down 16 third multiplied with AE, right? But I haven't done
Yeah.
it yet. Let me try to use the reciprocal, which makes sense that AE equals to 160 multiplied by the reciprocal of it. So it's going to be 3 times 16, right?
Yeah.
Let me cancel each other out. So 160 divided 16 is going to be 10. So whereas AE stands for 3 times 10, it's going to be 30.
Yep.
Did you get it?
Yeah.
Okay. So we have done from this exam. Let me go for the other exam that you sent it to me. Okay, just give me a minute.
Okay.
I'm trying to save it. So the first one, So this one sounds like a pretty symbol.
That's it. Yeah, that's pretty easy.
Okay.
You just do what's in the brackets first. So, uh,
I tend to
so
use
you
the
four
first.
times you do 4 times 5, 4 times 1, 5 times 3, 5 times 4.
Yeah, right. So works. So 2/3. As you told me, I need to multiply them firstly. So it's going to be 20. This one's going to be 4. This one's going to be 15, right?
Yeah. So it's 19 over 20.
Yeah, so it's going to be 2/3 multiplied by 19 over 20, right?
Yeah.
So you can make it simple.
So 2 times 19.
20 divided 2. It's going to be 10. So we'd end up with 19 over 30, right?
Yeah.
I think this one, non-calculator, don't have to use it, right? Oh my God, this doesn't work. Wait, hold on. It's been lags. Even go. Okay. The other one, what I want to do, this one sounds like a function, which makes sense. Now he asked me to get what is f of -3. So, what do you think? So it's going to be f of -3, right?
X squared minus 2.
No, wait, hold on. It's not x squared. This one is x to the power 3, right?
Yeah.
So this one sounds like -3 power 3 minus 2. So this one sounds like -3 times itself 3 times. So it'd end up with -27. Let me write it. -27 minus 2, which is going to be -29, right?
Yeah.
Okay. The other one. This one sounds like a cone. So what is look at this one. He told me that we need to calculate the volume of the cone. What is
Yeah. So half times base times height
what
times
is
pi.
I mean the cone and cylinder. The cylinder is pi square radius height, right? You want to get this one to remember the rule that we need to follow it. But this one, it doesn't look like a cone. But I think he this one. I think it's been given. Let me check. Yeah, it's been given there. Anyway, so all that you need. So it's gonna be. It looks like cylinder, but we get only one difference. This one sounds like third, right? I told you that the volume of cylinder is pi squared is height, but this the only difference that we have, you have to write third, right? So let me write it. That the volume equals third pi squared is height. You get it?
Yep.
So the point is, let me take a look. This one sounds like a diameter. I don't have the radius, but remember the radius is going to be the half of diameter. So what I want to do is just try to divide this one with 2. So it's going to be 10 centimeter, right?
Yeah.
Okay. So volume equals to 1/3 multiplied by pi also has been given, I think. That's 3.14. Let me write 3.14 multiplied by the radius. What is the radius?
What was I say? 10. Wait, what was I say? Yeah.
10 squared, right? Multiply with the pi.
60.
Right? So you write 1/3 multiply 3.14 multiply by 100 multiply by 60, right? Let me try to make it simple. 60 divided 3, it's going to be 20, right?
Yeah.
Times 314, right?
Yep.
I think it's easy. So
yeah. 6. Okay. Yeah.
So let me write 0. 2 times 4 is 8. 2 times 1 is 2. So it's gonna be 6,280. Did you get it?
Yeah. Yeah.
Do it again, understand it.
Now understand it.
Let me go a little bit further to something else. But I need to tell you something about the circle. No, look at this one. This one's called circumference. Now, the point is, I need you to differentiate between a couple things. The first one, this one sounds like the center, right? Center of the circle, which makes sense. This one is called central angle, right?
Mm-hmm.
So this one's central. But what about this one? This one's called inscribed angle. So how could you differentiate between them? No, the inscribed, the angle which has been drawn over the circumference, it's called the inscribed angle, right? So I'll say it again. So the inscribed angle, the angle which has been drawn over the circumference, is called inscribed angle. And we got something that's really interesting. Let me share it with you. So the point is that we got a relation between the central and the inscribed. Whenever we have the inscribed, for example, if this one sounds like 70, and all of a sudden he asked me what x stands for, so I think that we get a relation between them. They subtended with the same arc, which makes sense that central is going to be the double of this, the double of the inscribed. So if you want to get what x stands for, you have to tell me this one's going to be the double of it. So it's going to be 2 times 70, which is supposed to be 140. Did you get it?
Why is it double? Surely it's smaller.
Because the central, look, no, it's not smaller than it. It's going to be more, I mean, much more. This one sounds like the double of it, which makes sense. And we have a relation that between the central and the inscribed, the central is always the double of the inscribed whenever they subtend with the same arc. Look at the arc. This one sounds like the same arc, right?
Yeah.
So we got a relation between them. Let me tell you another thing. Can you tell me what does it look like? This one also is inscribed, right?
Yeah.
Let me erase it. What about this one? This one also is inscribed, right? So
Yeah.
we have a double inscribed, but they subtended with the same arc, which makes sense. They are equivalent. They have the same measure. Whenever we have the first one is 70, the other one also 70, right?
Yep.
You get it?
Yeah.
Whenever they have the same arc, so they must be equivalent. So the last thing I need to share it. So that if we have inscribed, which has been drawn in a semicircle, is always 90. Let me show you. If this one, you figured out this one sounds like a diameter. No. So this one is diameter, right? Look at this one. Passes through the center, which makes sense. AB is a diameter. So what does it look like? Look at this one. So this one sounds like inscribed. You don't have to get the measure of this one, because this one's always equals to 90. So even if he doesn't mention it, by the way, he doesn't mention it, he will not mention it. You have to know it by your own. This one always equals to 90. Did you get it?
Yeah.
Okay. I need to share with you another thing. Look at this one. What does it look like? This one also sounds like inscribed, right?
Yeah.
But what is this? This is called a tangent, right?
Mm.
So this one, let me write it. This one is tangent, which makes sense. So we have a line which touches the circle in only one point. It's called tangent, right? But we have something that's really interesting. Look at this one. This one is inscribed, right? We define it from just a little bit of time. So this one sounds like inscribed. But what is the relation between the inscribed, right? If we have inscribed, we have a tangency angle, they subtend with the same arc, so they are also congruent. I'm going to show you, okay? But let me try to return back to this example. Look at this one. So I think you've noticed something that's really interesting, right? But he asked me what is the measure or what is the side of the angle ACE? What is ACE? ACE. Ask me about this one, right?
Yeah.
Okay. So the point is, I need to tell you everything saying, but the point is, look at this one. I really care about this one. This one sounds like isosceles triangle. Do you know why?
Why?
So all radii in the same circle are congruent, even if he doesn't mention, right? Which makes sense. I know that OE is congruent to OD. I got something that's really, really important. Look at this one. This one sounds like isosceles. If I told you this one, it looks like an isosceles triangle. I got only one angle, the vertex angle. But by the way, I have the ability to get the measure of the two other angles, right? So if you try to subtract 180 minus 70, so this one's going to be 110, right?
Yeah.
And then have to divide them by 2 because the base angle are congruent, right? Which makes sense. They have the same measure. So 110 divided 2. So each one of them equals to 55. This one is 55 and this one also is 55, right? If you understood this example, you'll be able to do this one. Look at this one.
180 minus 68.
Yeah, this one also 68, right? Because
Yeah.
OE, no, wait, look. My bad. Those are congruent, right?
Yeah.
Which makes sense. This angle can be the same thing of this angle as well. Get it?
Yeah.
Okay, so it's going to be 180 minus 68 divided by 2. So this one's going to be 112, right? Divided by 2. So it's going to be 56. So this one is 56. And this one also is 56, right?
Yeah.
And by the way, I have the ability to get this one also, right?
Mm-hmm.
You have a linear bear. Let me write it. I don't know why did I erase it. So this one sounds like a linear bear, right?
Yeah.
Which makes sense. If this part's 68, so 180 minus 68, so this one's going to be 112, right?
Yeah.
And I have to do the same thing. This one also, let me highlight it. This one also looks like a nice Swiss triangle, which makes sense. Could apply 180 minus 112, right? Divided by 2. So this one's going to be 68 divided 2. So this one's going to be 34. And this one is also 34, right?
Yeah.
Oh, wait, hold on. Let me take a look. I need to end up the meeting right now and try to rejoin from Simlink.
Okay.